Hello and welcome to the solutions video for our April 14th assessments. So I'm going to be doing it in a slightly different way as was predicted last time. It'll be loading shortly. But for the actual segments, I'm doing them in order of popularity, as we can all pick our own skills to assess. So RF6 and EB4 were the most popular and so forth. And I will keep doing the timestamps as we go. So we're starting with RF6 as the most popular curricular outcome, then move on to M4, AN2, AN3, and so forth. And this time around, nobody requested RF4, RF7, or RF9. So here, we want to convert the equation y equals 8 over 5x minus 1 into other forms. So one is slope point form at the point where x equals 9. Well, we're going to need the y for that as well. So doing it algebraically, if y is 8 over 5x, that is a terrible 5. Again, internet connectivity seems very sensitive with this online whiteboard. And then minus 1. Well, when we substitute 9, we get 8 over 5 times 9 minus 1. That is 72 over 5 minus 1. Or 67 over 5. So that's our y-intercept. Of course, for full credits, we should have that right here, or all of our rough work. Either type it in or hand in the scrap paper. But now we have, a 67 over 5. So, slope point form. We now have both coordinates of our point. Y is 67 over 5. Our slope is 8 over 5. And then our x is 9. Now, converting to general form is easier starting from our linear equation, our slope-intercept form that we had up above. So I'm going to take that first form. Y is 8 over 5x minus 1. Multiply it all by 5. Simply because that is our visible denominator. That gives us 5y equals 8x minus 5. So then 8x minus 5y, and then I will accept either minus 5 equals 0 or 8x minus 5y equals 5. I will take either of these forms. So 8x minus 5y equals 5 is a little bit faster to type. So next, we have three equations that we want to match with their graphs. So graph 1 has a y-intercept of 3 and a slope. We go up 1, 3 to the right, slope of 1/3. That actually fits our slope-intercept form here. Now graph 2. If you go through carefully, we'll see they're the same options, just randomly sorted in a different order. So graph 2 has a y-intercept of 2, and the slope looks like it's a negative 2 over 5. So it's not our linear one. That has to have a y-intercept of 2. Now, this one, when x is 0, y is 2. When y is 0, x is 5. Those 2 points are both on our graph. That's a fit. Here, if x is 2, that would be a -8. So a -32 over 5, y would be a fraction, not a whole number. With that -32 over 5, it would be a negative number as well. So it can't be graph 2. And this last one would have the perpendicular slope to part B. So if at part B, we know 2 points are correct, and 2 points completely define a line, and the other one would be perpendicular. So which matches graph 3? Again, we see that they're the same options. Nothing here looks perpendicular to 2, so we could probably eliminate the other general form. Slope point form, we're looking at a point that passes through, or a line that passes through point 310 with a slope of 4/5. So, or sorry, 10/3, not 310. X is 10, y is 3. That fits this blue line. And it goes 1, 2, 3, 4 up. Well, 1, 2, 3, 4, 5 right. So, yes, that is a good fit. Now, for M4, we're getting into trigonometry. We need to solve this triangle. We are given our 2 perpendicular sides. So angle A, in that case, we're given the opposite and the adjacent. So opposite and adjacent, so katoa goes on tan. So the tan of angle A is the opposite over the adjacent, which means angle A is the inverse tan of A over B, so 24.8 and 36.8. So going to our calculator, taking the inverse tan, 24.8 over 36.8, and I'm getting, for all the digits in the display, 33.976544404. These are almost all irrational answers. So that'll be a 34.0 to the nearest tenth. 34.0. Side C, we can get with the Pythagorean theorem. The square root of 24.8 squared plus 36.8 squared is 44.37657039, or to the nearest tenth, 44.4. Angle B, the opposite and adjacent change places. So instead of the inverse tan of 24.8 over 36.8, it's the inverse tan of 36.8 over 24.8. Which works out to, I was looking at the wrong number there. That's why it wasn't making sense. So yes, it works out to a 56.0, which does make sense. Angles A and B have to add up to 90. So we could have said, we could have said 90 minus 34 to get to 56, but I always recommend going back to the original information provided by the question if it's humanly possible, so that mistakes in part A don't turn into mistakes in parts B, C, and D, and so forth. Now here, consider the diagram given below. Buildings A and B are 11 meters apart. 2 ropes that join the buildings together. The top rope goes from the top of building A to the top of building B. The angle formed is 32 degrees. The The bottom rope, measuring 40 meters, goes from the base of building A to the top of building B. So we need the length of the top rope. Well, we know the buildings are 11 meters apart and that the angle between is 32 degrees. So we're looking for the hypotenuse in a cosine problem. So this is the adjacent divided by the cosine of the angle. So that's 11 divided by the cosine of 32. That gives us 12.97096244. Or in this case, for the first one, part A to the nearest tenth is 13.0. And that's meters. Now the angle of depression, that is this angle here. That's the angle when you go from looking straight ahead to looking down. That is our angle of depression. So we want this angle, it says to the nearest whole degree. Well, we know this rope is 40 meters. We know the distance, D, is 11. So this is another cosine problem. The adjacent is 11. The hypotenuse is 40. We need the angle. So the inverse cos of 11 over 40 to the nearest whole degree is 74 degrees. All right, looking at AN2. We've got some written response here. 4 written response which have multiple correct answers. If we want an irrational number between 6 and 7. One way to have an irrational number is to have the square root of an imperfect square. Sorry, it's between 5 and 7. I said 6 because I was thinking 6 is exactly between them. 6 squared is 36. So if we do the square root of 37, really the square root of any number between 25 and 49, except 6, or except 36, which is the perfect square, that satisfies this criteria. Now, a rational fraction, so we want to make sure we have a denominator other than 1, between root 51 and root 72. Well, root 51 is greater than than 7, but less than 8, because that's root 49, root 64, and root 81. So we want a fraction typically near 8. So let's say we have 8 and 1 over 100, right? This would be just off of 8. It'll be rational. Well, that we can write in a fractional form as 801 over 100. So yes, it's an improper fraction, but it works. Now an integer between these two numbers, 75 times 2 is 150, so this is less than 2. 328 over 37, that's going to be more like 8 point something. Works out to 8.86. So the integers between them, we could pick any one of 2, 3, 4, 5, 6, 7, 8. You won't be penalized if you list all or partial. But these are these 7 numbers we have to pick from. Now finally, an irrational number between 2 over 3 and 4 over 5. All right, so the least common denominator of those is 15. Really, we're looking for something between 0.6 repeating and 0.8. So anything in there, 0.6 repeating and 0.8. Okay. So 2 pi is about 6.3. If I take 2.5 pi, that works out to 7.85398, so it's an irrational number because it's a multiple of pi. And it is between the decimal representations of these two numbers, except multiplied by 10. So we can use that to build it. So I originally said 2.5 or 5 halves of pi. But that is about 10 too high. So we can divide it by 10. And we end up with a final answer of pi over 4. So pi over 4 is one of the possible answers. Yeah, that works out to 0.7853 and so forth. So aside from question 6, these all have either countably or uncountably infinite correct answers. 6 is the only one on the finite list. So these are far from the only correct answers, but these are correct answers. Which best illustrates the concept of irrational numbers? Although measuring the length of a piece of string, dividing pizza in equal slices, counting the number of apples in a basket, these would be integers or rational numbers. The diagonal of a square with sides of length 1, if we use the Pythagorean theorem, we'll find that the diagonal is the square root of 2. So that is a good example of irrational numbers. So that wraps up algebra number 2. Now, algebra and number 3. So our first one, when we evaluate this to the nearest hundredth, this is one we can actually put into our calculator as is. We can type it exactly as written. To the nearest hundredth, this is 1.25. In fact, it'll be exactly the same as 1 over 0.8. Now for our next one, to evaluate 0.25 exponent negative 3 halves, Radio went through the following steps using paper and pencil. So what is the value of k? You'll notice here, all we've done to the exponent is change the negative. So we will have reciprocated 0.25. That's going to be 4. So now for exponent 3 halves, that'll be 8. So you can get to L pretty quickly just by typing in the original equation into your calculator. To get k, you have to do it by hand, or at least recognize which changes were made to put that into your calculator. So if the exponential expression 1 over 4 exponent k is equivalent to 2 times 2 times 2. So this is saying, effectively, because 4 is 2 squared, what we really have is 2 to the negative k, or negative 2k, I should say, equals 2 cubed. That only works if the exponents are equal. So isolating k, that is a negative 3 over 2. Now here, for 5 over 9 to the 4/5 to equal 9 over 5 to the m over n. The values of m and n are. Typically, our denominator here, the 5, comes out as our index. The numerator stays inside. We've also inverted or reciprocated the 5 over 9 to make 9 over 5. That means one of them has to be negative. So that gets us b or c. So b is the one that has 4 as the numerator, 5 is the denominator, and we've got a negative on one of them. Number 6. Farian simplified the expression using the given steps. Step 1, he's taken the cube root and written as exponent 1/3. Nothing else has changed. That's valid. The denominator, he's just taken that negative 1 and applied that exponent all the way through. So step 1 is fine. Going from step 1 to step 2. He's now taken that 1/3 out here and moved it across. The cube root of 8 is 2. 1/3 times 2 is 2/3. 1/3 times -2 is -2/3. Our numerator is okay. Checking our denominator, we've had no changes. So now going forward, he's simplifying. 2 over 2 to the -1 is not the same as 2 over -2. Step 3 is the error. The 2/3 over 2 will be the 2/3 minus 2. The -2/3 over a -1 is a -2/3 plus 1. These simplify correctly, so the only mistake is step 3. If it's only one mistake, why I say is first error. Some of these problems genuinely do have 2 errors. Most of the time, it's so that if the student doing the problem makes 2 errors, they don't know which one is their own and which one is from the problem. All right, that takes care of algebra number 3. Now we'll do relations and functions 2. Sketch each of these. So we'd either do it on paper. Actually, it's really paper. It's the scrap paper or the answer sheet. A linear relation, which is not a function. How do you get a straight line that is not a function? That straight line has to fail the vertical line test. That function has to be a vertical line. There's no other way. A function which is continuous but not linear. Okay, we might as well plot these. So again, a vertical line, something like x equals 2, we'll do that. When Desmos finishes loading, we'll come back to it. Continuous but not linear could be any smooth curve, but it actually has to curve. So something like this is continuous but not linear. Discrete relation, which is not a function. So discrete relation means we have a collection of points. If it's not a function, that means 2 distinct points share an x value. So here, x equals 2 is linear, but not a function. X squared is a non-linear function. A discrete relation, which is not a function, we can do that with the table of values. Say 1, 2, 3, 4, 5, we'll stick in another 1. And then here, all that really matters is that those numbers do not match. We zoom out a little bit so they all appear. Yeah, it turns out we've got a little bit of a straight line, another jump, but it's that x equals 1 mark where we have an intersection here and down below. Intersections at y equals 5 and x equals -3, or y equals -3. So that's a discrete relation which is not a function. And then a continuous relation which is not a function and not one of the above graphs. How about a circle or an ellipse? Those would work. Now, for marking, they don't pop up unless there's something written in the box, so I'm going to remind myself or whoever's grading it to look for the annotations. Now, is this mapping a function? The arrow goes from the left to the right. That makes the arrow, the left, the domain, and the right is the range. So no, not a function, because 2, 6 and 2, 7 they fail the vertical line test. A vertical line at x equals 2 would hit both of them. That is not permitted. So because now the function fails the vertical line test at one point, it fails it at all points. All right, moving on to relations and functions 3, all about slopes. Which segment has a slope of 0? Well, slope is change in y divided by change in x. So our change in y has to be 0. Oh, that's segment 4. That's the horizontal line. 2 is the negative slope. That's the one that comes down. 3 is the positive slope. That's coming up. And the undefined slope is the vertical. That's line segment number 1. Now, which is the steepest? That is the function that has the highest magnitude of slope. So it would be 1. All right, so now we are moving into measurement 3, surface area and volume. In biology, the surface to volume ratio is important for single-celled organisms. If the ratio, which has the surface area in the numerator and volume in the denominator, is high, then the cell does a more efficient job of absorbing nutrients and expelling waste. So we imagine two cells that are 1 unit across in whatever units fit. One is spherical with diameter 1, the other is a cube, side length 1. Which has the higher surface to volume ratio? Okay, so if we look at the sphere first, the surface to volume ratio is surface area over volume. That's 4 pi r squared over 4/3 pi r cubed. We can cancel the 4's, cancel the pi's, and cancel 2 of the r's. So after the cancellations, the surface to volume ratio is 3 over r. If the diameter is 1, the radius is 1/2. So this is 3 over 1/2, or 6. Now for the cube has a side length of 1. So that's 6 s squared over s cubed. 6 over the side length is 6 over 1, which is 6. So at this scale, they actually have the same surface to volume ratio. The cube will have a bigger volume. Right? If r is 1/2, then the volume of the sphere would be 4/3 times pi times 1 over 8, or pi over 6. Whereas the volume of the cube is 1. And pi over 6 is definitely less than 1. So here, the surface to volume ratios are equal. We don't have one that is greater than the other. We do need to see this work in order to get full credit. But yes, the surface to volume ratios are equal at this stage. We might notice here our sphere is about 3 over r. Our cube is 6 over s. If we keep doubling that radius or that side length, we are going to keep lowering the surface to volume ratio, and higher is better. This is why evolution guided us to a large number of small cells instead of a small number of large cells. Okay, so now a right cylinder has an area of 238 square centimeters, or 238 pi square centimeters, and a radius of 7. What is the exact value of the height? So the area of a cylinder is 2 pi r squared plus 2 pi r h. That is on the formula sheet. Pi r squared is a circle, We have a circle on top and a circle on the bottom. If we unfold the curved side, that turns into a rectangle. One side is the height, the other is the circumference, 2 pi r. Doing our algebra first. That's the area minus 2 pi r squared divided by 2 pi r. So we solve for height. We subtracted the 2 pi r squared from both sides. Left us with our numerator here equals 2 pi r h. Then we divide by 2 pi r. So our area is 238 pi centimeters squared minus 2 pi. And then our radius is 7 centimeters. So our height so our pi's will cancel. So we have 238 minus 98 as our numerator. Denominator is 14. So our height is 10 centimeters. Again, including all that work for full credit. Okay, so relations and functions 5, focused on domain and range. So, relation A, we want the domain and range. The domain. Okay. So X is an element of the set, including everything in our oval on the left, and our range for another mark. Okay. Our range here, Y is an element of the set on top, 0, 1, and 6. Now here, relation B, these arrows continue to infinity. They're getting steeper, but they are still moving slightly to the right. So our domain is X is going to be a member of the reals. So X is a real number. That's our domain. Forgot to write that first, I'll write it after. Now the range, this one, Y, has an upper limit. It seems to peak at X equals 4 and Y equals 3. So here Y is less than or equal to 3. Domain of this relation, that's the set of the X values. So that's a -2, 1, 3, 4. That is number 12, or part D. All right, moving on to measurement 1. So we're going to invent our own unit of measure. Find some way to measure something for full credit. So this is out of 3, we need to hit the 3 bullet points. What quantity it measures, distance, time, speed, angle. A definition, and we can independently measure and verify with consistency, and the purpose for the unit. Well, for this one, let's take a slightly different version of the astronomical unit with the average Earth-Sun distance. And we will make a unit, we'll call it the LU. Instead of astronomical unit, it's the lunar unit. And it is the average distance between the Earth and its moon, which technically is not a moon because its orbit is always concave towards the sun, not always concave to the Earth. We're a double planet. If Earth disappears, the moon would stay in orbit, while if Jupiter disappeared, its moons would scatter. But we call it the moon. So that is our second bullet point. That's the definition. It measures distance. That's part of it. We'll just repeat it. And just as the astronomical unit is useful for figuring out the dynamics of other planets, we'll do this to set up satellite physics. It's a better understanding of Earth dynamics. So we can use the moon as a model and get that to more accurately determine how to set up satellites around Earth. So, which of the following would be most appropriate to use when measuring the height of a trophy? It's got to be one heck of a trophy to need a meter. Centimeters seem reasonable. We'll see if there's a better answer along the way. Kilometers would be massive. We are not carrying that trophy around. Not to mention trying to find a case for it. Millimeters would be an extremely unimpressive trophy. So centimeters is the most reasonable. All right, we have a school field that's shaped like a rectangle with a semicircle attached to one end. Anjali wants to determine the perimeter of the shape. She walked the perimeter, estimating each stride to be 1 yard. And Anjali estimated the perimeter to be 156 yards. So if x is 30 yards and y is 38, what was the error of Anjali's estimation? So y is 38. We have 2 units of 38 in length. We have 1 unit 30 in length. And then we have the semicircle. So instead of being 2 pi r, it's just pi r because it's half a circle, where the radius is 15. So we have 38 plus 38 plus 30 plus 15 pi works out to 153.12. So these should be the nearest whole yard. I'll have to remember to specify that. It's set up for whole numbers. It's off by 3, which is a pretty good estimate. I don't think I could walk around a field and estimate quite that accurately. To do it that way, you have to make sure you're taking consistent strides. All right, now into algebra and number 1 with roots and factors and so forth. So how are factors and roots connected? Factors are only used in geometry. We could stop right there. That's false. Factors and roots are unrelated concepts. False. So these two are very similar. Factors show how numbers can be broken down while roots show how they can be built up. Or factors build them up and roots show how they can be broken down. It is this one. The factors show how numbers can be broken down. So, when 4 and the 5th root of 7 is written as an entire radical, the radicand is... Okay, so we have 4 and the 5th root of 7. That is 4 exponent 5 times 7, or 2 to the 10 times 7, which is 1,024 times 7, or 7,168. So a student was asked to find the greatest common factor and least common multiples of the numbers m and n. The student is not particularly organized and wrote 3 numbers, a, b, and c, on 3 different scraps of paper. If the relationship says a is less than m, b is between m and n, and C is greater than N, identify which is the GCF, which is the LCM, and which is neither. Well, the GCF has to be less than or equal to each of our two numbers. You can't have a common factor that's greater than the number. So therefore, the GCF is A. Similarly, the least common multiple has to be divisible by each of these numbers with an integer answer. So it's got to be greater than or equal to. We can even already limit these between M and N to just M and N, because those are, we know N is greater than M. So then the LCM is B, and C is neither. You cannot have one of these in between. All right, expand and simplify. We have 2x plus 6, 2x minus 3, and 3x minus 7. So let's do this in stages. Use the box method. 2x plus 6. And 2x, I think, was minus 3. And I apologize for not closing my email app like I usually do before I do these. Keep getting the notifications popping up. All right, so here's our box. So here we have a 4x squared, a 12x, negative 6x, and a negative 18. Collecting our like terms along that diagonal, we're going to have a 4x squared plus 6x minus 18. And I have intentionally written those with space between them. So that'll be the heading of our new box method with a 3x minus 7 on the other side. So here a 3x and a minus 7. Set up our box. So here, 12x cubed, negative 28x squared, 18x squared, for that 6 times 3 and the x times x, a negative 42x, the 3 times the negative 18, we have a negative 54x. And finally, a negative 18 times a negative 7. 8 times 7 is 56, so that's 126. So we have 12x cubed. These ones, negative 12x squared, negative 96x, and a 126. So there we go. We have 12x cubed minus 10x squared minus 96x plus 126. So when this is expanded and simplified, here we're only looking for the x squared term. So that's going to happen from 5 times x squared and 3x times 7x. So that's a 21 and a 5. So the x squared term is 26x squared because we just want the coefficient. We just want 26. Here, we multiply this out and solve for a, b, and c. So we have 3x times 7 minus x 3x times 7 minus x minus an x plus 2 squared. Multiplying this first one out, we have a 21x minus 3x squared. Product of perfect squares form. We could jump to our final factored form if we have that memorized, as I've been recommending. So we have a negative 3x squared. We have another minus x squared from here. And we have a 21x outside minus the 4x from inside the brackets. And then minus 4 is our only constant. So this is a negative 4x squared plus 17x minus 4. So that's a negative 4x squared plus 17x minus 4. All right, so now we need to find the area of this shape. Which of the following simplified expressions describes the area of the side view? Now we could say that's a 3x plus 1 times 4x for a big rectangle and break these into strips, or we could say these are all x. So you have 1, 2, 3, 4, 5, 6 x squareds here. So that's the 6x plus 1 times 4x minus 6x squared. 4x times 6x is 24x squared minus the 6 gives us an 18x squared. So it's A or B. Plus the 4x. There's nothing else going on with the x's. So that wraps up algebra number 4. All right, getting into algebra number 5, factoring these. We need numbers that multiply out to 11 and to 20 that we can add and subtract to get 49. So the factors of 11 are 1 and 11. Factors of 20 are 1 and 20, 2 and 10, or 4 and 5. So given that one of these is the start of one term, the other is the start of the other, and we have to pair it with something, that's 2, 4, 6 combinations we could check. Knowing they need to get to 45, well, for this, our 11x, that's prime, so there's only one combination. If the 11 is multiplied by 4, and the 1 is multiplied by 5, then we have 44 plus 5, which is 49. All of our signs are positive, so we can keep that. X plus 4y, 11 plus 5y. Oh, I just said 11, I should say 11x plus 5y. That factors the expression completely. The same thing here. We need numbers that multiply out to make 2 and 21. And when we cross multiply, we can get 17. Well, 21 is 3 times 7. 7 times 2 is 14. So if we have a 7x plus y times a 3x plus 2y, 7 times 2 is 14, 3 times 1 is 3, 14 and 3 makes 17. And here, the student factored the quadratic expressions. The quadratic that the student factored incorrectly is. Okay, we check the first one. 15 times 4 is 60, And a negative 15 minus 4 is a negative 19. Quadratic 1 is okay. Quadratic 2. Yeah, we have a 3x cubed minus 75x, so we pull out that 3x. We're left with x squared minus 25. That's the product or difference of perfect squares. 2 checks out. 3, we start with a negative 9x squared. Both of these 3x terms are positive. 3 lost a negative sign. We can double check. If we multiply out 4, we'd have a 2x squared plus 3x plus 1. And then when you multiply that by 2, it does check out. So 3 is the issue. We have at the very least lost a negative sign. But I see here all these terms are positive, so it's more than that because this cross term would need to be negative 2. So this should have been 3x minus 2 times 3x minus 2 with an overall negative on the outside. Factor this completely. This is the product of perfect squares. The square root of 16 is 4. Square root of 1 is 1. 4 times 1 and then double it for the cross term gives us 8. So this is 4x plus y, and we square the whole thing. Now, which two polynomials cannot be factored? Well, here, 2 and 3 are the lead, or the quadratic term, our leading coefficient, and our constant both times. So we need numbers that multiply out to negative 3, or multiply out to 3 and 2, and when you cross multiply them, we get that middle term. The fact that our 3's are consistently negative tells us that the signs have to be different in our factors. So we are going to have we can have a 2x minus 1 and x plus 3. We can have a 2x minus 3 and x plus 1. 2x plus 1 and x minus 3. Or a 2x plus 3 and x minus 1. These are the 4 possibilities that will get our first and last to work out. So we have to see which cross terms they produce. So yes, our 2 times 3 is a positive 6, minus 1 is a positive 5. So B works. Flipping the signs on that, looking down here, negative 6 plus 1 gives us our negative 5. So both 5's work. So we found this one has a 5x cross term, and this one has a negative 5x cross term. 2 minus 3 gives us a negative 1x. 3 minus 2 gives us a positive 1x. The 7's are out of place. Had this 3 been positive, we could have produced the 7. We could have had a 2x times 3 to make 6 and then added 1. But that's not what we had. All right, moving on to relations and functions 1. Which of the following variables is discrete? This is something, it could be integers, like a counted quantity. It's got to be something you can graph without keeping your pencil on the page the whole time. No, there's some set of variables are not allowed. Goals in soccer would be discrete. You can have 3 goals, you can have 4 goals, you can't have 3.5 goals. You can average 3.5 goals over the course of the season, but you can't have 3.5 goals. Now, Kelly works at a bowling alley. Shoe rental is $5 and it costs an additional $7 per game played. Well, you're not going to play a half a game, or if you do, you're still going to get charged for that entire game. So it's got to be discrete. So it's the first or the last. It's going to be the one that starts at $5 when you have 0 games and then goes up. In this case, 5 is our intercept. $7 per. Per is a keyword telling you this is a slope. The slope is 7. And kind of already covered this, but yes, the data has to be discrete because you can only play a whole number of games. So 20, or this question, might tip you off that if you picked B or C in the first one, maybe you should come back and take a look. Well, it probably wouldn't be B or C on yours. They're random. So which of the following is an example of a discrete variable? Again, number of tickets. It's a counted quantity. 3/4 of a ticket is not very useful. Now, a theater has 15 seats in the first row, 20 in the second, 25 in the third, and so on. Which graph represents the situation? If we look at this, these are going up by 10. It's 225 and 335. This is it. 115, 220, 325. You're not going to have a fraction of a row. All right, Relations and Functions 8 on function notation. We want to evaluate and write a simplified expression for each of the following given this first function. So 2x squared minus x plus 3. So if f of x is 2x squared and minus x plus 3, f of -4 take this nice and slow. We put in -4 where the x is. (16 times 2 is 32. Minus a -4 is +4. Plus 3. So part A is 39. Part B, we're substituting x minus 4. May seem counterintuitive, but it's totally valid. Wherever we used to see x, now we write x minus 4. So product of perfect squares, that's x squared minus 8x plus 16. Minus x plus 4, just bringing that negative sign through the brackets. Moving the 2 through the brackets, 2x squared minus 16x plus 32 minus x, combining the 4 and 3 to a plus 7. Now we collect like terms one final time. 2x squared minus 17x plus 39. So 2x squared minus 17x plus 39. Now, here, a dog kennel charges a flat fee of $50 and medical insurance of $35 per night. So that's described by this equation. 35 or 50 is our constant, 35 is our slope. So C7 is 50 plus 35 times 7. And 35 times 7 is 210 plus 35, so that's 50 plus 245. That is 200. I wanted dollars. It's $295, and that is the cost of staying 7 nights. Here they're giving us the flip side. The cost is 120. How many nights is that? Well, 120 minus 50 is 70, divided by 35 is 2. So that is a 2-night visit. All right, our last section, measurement 2. Edmonton and Calgary are 279 kilometers apart. If a map depicts them as being 2.78 inches apart, then the scale of the map is what? Okay, well, we need to find the difference between these numbers. So we have 2 7/8 inches over 279 kilometers is 1 over our scale. The scale is the larger number. So 2 7/8 inches. Times 2.54 centimeters per inch. So 2 7/8. Let's go to 2.54. So the distance on the map is 7.3025 centimeters. So our scale, 279 kilometers, is 279,000 meters. Add 2 more zeros to put that into centimeters. And we're dividing that by 7.3025. And to the nearest whole number, that is 3820609, and then it's 0.38. This question should specify the nearest whole number. That's 2 of them. I'm going to have to remember to make that comment during the test. If I forgot to say that during the test, remind me, and I will manually score these questions. So we want to convert 18,160 ounces into UK long tons. Okay, well, 1 long ton is 2,240 pounds. So 18,160 ounces. 1 pound is 16 ounces. We divide that number of ounces by 16. We have 1,135 pounds. 2240 divided by 1135. To the nearest hundredth, it's 1.97 UK long tons. Now, ounces to kilograms. 1 ounce is 28.35 grams. So 28.35 grams times 24 tells us 24 ounces is 680.4 grams. Divide by 1,000 to turn it into kilograms, and it is 0.68. Now rounded to the nearest whole centimeter, 5 feet 6 inches. 5 feet, 5 times 12 makes 60, plus 6 more, this is 66 inches. times 2.54 gives us 167.64, or to the nearest whole, 168 centimeters. Finally, a hall measures 30 yards by 25 yards. It's to be completely covered by a 6 by 5 foot rug. Each rug costs $37. Now, it's really tempting. 30 is a multiple of 6, 25 is a multiple of 5, to just say, okay, that is 5 times 5, that's 25 rugs. These are yards. These are feet. So this 30-yard long is 90 feet. 75 yards is 75 feet. 90 divided by 6 is 15. 75 divided by 5 is also 15. We have 15 by 15, or 225 rugs. At $37 each, this is 8,325 rugs. Or dollars for the 225 rugs. Okay, after verifying the answer key, I did find an error in measurement 2. Thankfully, it's our last of the outcome, so watching it continuously, you should hit it. This one, I had the ratios upside down. 18,160 ounces. You divide that by 16, it's 1,135 pounds. I did 2240 divided by that number. 1,135 is closer to half a pound. I had that ratio upside down. We didn't want 1.97. We wanted the reciprocal of 1.97. It's 1135 divided by 2240. So with this, when this loads, we now have the perfect score we are looking for.